All right, any more questions? Sorry about that. Okay, so we don't have a lot of time left, so which is good because I wasn't able to finish my lecture notes, but I was planning to wing it.
Sir, can you ask questions regarding the assignments, like this one?
So I was going to have a special session on the assignment in a few days, if that's okay.
Oh, but I had a question related to definition, not
Oh
exactly.
yeah, of course, yeah.
Like, there is a question related to the chemical potential related to when we ionize a hydrogen. So, so it says that the hydrogen decomposes into a proton and an electron,
Yeah.
and we have to show that the chemical potential of the hydrogen is the sum of the chemical potential of proton and electron. But the chemical potential in this context didn't make quite sense to me. Like, how do I understand it from the basic definition of chemical potential?
Uh, yeah, that's a good question. I mean, that's more of a conceptual question, I think. So, yeah, I mean, if you were to ignore the interaction between the proton and the electron, or think of it as a higher order, higher order interaction, then what would be the partition function of the hydrogen, and how would you be able to express that partition function in terms of, say, the electron and the proton?
Oh, okay, I see.
Right. I mean, the thing is that in this case, uh, protons and electrons cannot really turn into each other, right? So as far as counting those things are concerned, you can treat them. That's what the chemical potential does, right? So if you look at the partition function has a part in the exponential, which is the chemical potential, another part, which is the energy, right? Now, what we're doing here is that we can kind of, ignore the energy for a moment, right? Because, or the interaction term in the energy. Okay, so I think about that, right? I mean, it's a very easy answer, so it's not something complicated. Okay, any more questions?